Hi everyone, welcome to lecture 6. As you may remember in our last lectures, we have learned about equations and inequalities, and we've seen, of course, different ways of solving equations and inequalities. And we've seen mainly the linear equation. Of course, I cannot say we have seen quadratic, but yes, we have seen even the quadratic a little bit. We've seen how to solve. We have seen different ways of solving quadratic equations, one of which is the quadratic formula, which can be used for any type of quadratic equation. And in chapter 2, we're starting chapter 2. So in chapter 2, we will learn about functions and relations. So the first section of chapter 2 will be about this rectangular coordinate plane, which sometimes call it Cartesian coordinate system, or just simply coordinate plane. So all these are the names that we use for this plane or this XY plane. Yeah, sometimes in some books you may see, of course, the name XY plane as well. So this is what we call the rectangular coordinate plane, and this is we have a vertical line which is which represents the y-axis, and a horizontal line which represents the x-axis. So in this rectangular coordinate plane, we have the y and the x-axis. They divide the plane into 4 different quadrants. We call this first one the first quadrant, or quadrant 1. Quadrant 1 is this one, and then we go anti-clockwise. So here, this is quadrant 2, quadrant 3, and quadrant 4. So we have these 4 quadrants. And then we have the origin, which is the point where these 2 axes meet. So this is what we call the origin. And the point, or the value of x at this point, is 0, and the value of y-axis at this point is 0. And this is represented by the point 0, 0. Okay, the first number is for x, and the second number is for y. And any point on this rectangular coordinate is represented by a pair of numbers, x, y. We use this parenthesis. So this is how we represent a point anywhere in here. The first number represents x value, and the second number represents the y value. So for example, if we have a point in here, if we have a point right here, what we look for is here, we go vertically down here to the x-axis, and we see what the value of x at this point is. So this point takes the value of x at this point. So let's say if this we call, let's say, a, then at this point the value of x is a. And for y, if this is b, then this becomes b. Therefore, this point is a, b. Okay. Okay. Now we know how to represent a point on the rectangular coordinate plane. We use paired numbers. Now, let's say we have 2 points on the plane, and we wanted to find the distance between those 2 points. Now, how do we find the distance? Because, well, if it is a horizontal or vertical line, it's not a problem. So, for example, if I have this horizontal line, well, you just count from here to here. Let's say this is 0, 1, 2, 3, and 4. Then this is just the distance between this point and this point is just 4, right? Well, how about if I have a point like this one? A line, I mean, sorry. If I have a point like this, it's not easy now to determine based on these lines, right? So how do we find the distance between between this point and that point, or just the length of this line segment that connects these 2 points? So we need to have a general formula to find such kind of distances, right? So for any 2 points, if you have any 2 given points, it could be, both of them could be in one quadrant or in 2 different quadrants. But let's say we have 2 different points, and let's call them P and Q. This is P and this is Q. We have point P and point Q. So point P is represented by x1, y1, and point Q is represented by x2, y2. And then the distance between these 2 points, we use the letter D to represent the distance, okay? Now we want to find this distance D. So I will use this point, or the value of x1, y1 and x2, y2 to find D. And the formula to find D is D equals to the square root of x2 minus x1, this is minus, the whole squared, plus y2 minus y1, the whole square. So all this is under the square root, okay? All this operation is inside the square root. So this is the distance between point P and point Q. This P and Q, they are arbitrary. They could be any points, okay? And we will see some examples like numerical. And another point is, if we have two given points like this one, P and Q, what is the midpoint of these 2 points? Okay, I cannot just guess, right? Of course I can guess, but I need to find the exact midpoint of this line segment, okay? And to find this midpoint, I only need the value of these 2 points, like the coordinates of these 2 points. I need x1, y1, and x2, y2. If you give me these 2 points or these 2 coordinates, then I can find the midpoint. And to find that midpoint, I need a formula, of course, and that formula is m equals to x1 plus x2. In this case, we add the 2 x's together and divide by 2, which means we find the average of the x values. X values are x1 and x2. And then we find the average value of the y values, y1 and y2. So here we have y1 plus y2 over 2. So since this is a midpoint, it's a point, okay? And a point is represented by paired numbers. It has to be something like this, a comma b, okay? And that's why we have the first point, the first number, x1 plus x2 over 2 is a number, comma y1 plus y2 over 2 is another number. So we have this form, okay? But the distance is a single number. It should be a number, a real number. Okay, now let's look at this example. Find the distance and the midpoint of the line segment whose endpoints are 3, 6 and -4, -1. So one advice I would suggest for you to do when you deal with such things is to draw the line, okay? Always try to do use to draw the xy coordinate or the so the first point is 3. The x value is 3. So I start with this one. You don't need to draw a line, vertical line, but that can help you. So you go vertically until you meet this horizontal line that starts from the y value, which is equals to 6. So 3, 6 is the line that intersect these 2 lines, the vertical and horizontal lines, okay? So here we have 3, 6, and the second one is -4. X value is -4, so I have -4 right here, and the y value is -1, so -1 is below the x-axis. These are the negative values for y, so it's -1, therefore it has to be this line, and this is where they meet. So this is the line, the point, sorry. Let me use the blue color. So here we have. Now, To draw a straight line here, this is the line segment now, with endpoints -4, -1, and 3, 6. Okay. So the question is, what is the distance between these 2 points? So we have the formula, straightforward. Just write down the formula, and the formula is x2 minus x1 squared plus y2 minus y1 squared under the square root. So let's plug in the values. X2, it doesn't matter which one you start with. You can consider this as point P and this as point Q, or vice versa. It's not a problem, okay? Since we have this square, it doesn't matter which one you start with or which one you subtract from which. So I will do this. I will use this one as x2 and that one as x1, or the other way around. It doesn't matter. Okay. If I say this one q, so let's say this is q x2 y2. This is x1 y1. Okay. Again, this is not a problem. You can start with whichever you want. Now x2 is 3, so put 3 minus x1 is -4, so -4 squared plus y2 is 6 minus y1 is -1, so -1 squared. And now what do we have? Here we have 3 minus -4. So we have 2 negatives. So negative times negative is positive. Therefore, this becomes 3 plus 4 squared. And 6, negative times negative positive. So this becomes plus 1 squared. And so we have 7 squared plus, again, 7 squared. And what is this? First one is 49. Plus 49, right? And this is, we can rewrite this one as 49 times 2, right? And we can write this one as, put more space here. We can write this one as square root of 49 times square root of 2. Okay, well, I'm just trying to simplify this one as far as possible. And now we can find the square root of it, because this is a perfect square. So square root of 49 is just 7, but 2 it's not a perfect square, so I leave it that way. So we have 7 square root 2. Okay, so this is the distance. This is the distance between the 2 points, the 2 given points. And the next question is, what is the midpoint? Now, if you look at this one, the midpoint, you would expect is somewhere, I don't know, somewhere around here. Yeah, somewhere around here, I don't know. But that's not good enough. So I have to find the point, the midpoint. And the midpoint, the formula for midpoint is m equals to x1 plus x2 over 2, comma, y1 plus y2 over 2. Now, you just plug in the values, and this will give you x1 is -4 plus x2 is 3. Sorry, this is not plus, this is comma. And y1 is -1 plus y2 is 6 over 2. So the first is -4 plus 3 is -1. So this is -1 over 2. And this is 5 over 2, right? -1 plus 6 is 5. So 5 over 2. Okay. Which is, you can leave it this way, or you can, I don't know, rewrite it so that you can find it easily. Well, yeah, that I think that's much better to leave it. But 5/2 means 2.5. So either way, it's both they're right. So I will just leave it this way. So this is the midpoint. And if you go back and look at the rectangular plane, -1/2 and 5/2, -1/2 is here, right? -1/2 is here, and 5/2 is 2.5. So we have 2.5. So the midpoint is somewhere in here, and that was our guess, right? Okay. So this is how we find the midpoint and the distance of a line segment which is connected, which has endpoints given. Now we have a little bit different question here. We have 3 points, 3 coordinates, and the question is, do these 3 points represent a right triangle? Well, how can I know if the 3 points represent a right triangle? I don't know. So let's put an xy coordinate. So 2 is somewhere in here. This is -6 and 2. And then we have 3. 1, 2, 3, and 1. So we have 3, 1. And the last one is 1, -2. So 1, -2 has to be somewhere in here. 1, -2. Okay, so these are the points. Now, if I connect these 3 points with a straight line, I'm not sure if they will be a right triangle, but we will see. We will see if they represent a right triangle. Let me connect again this. And now the question is, do you think this is a right triangle? Now, I'm not asking you just by looking at it to determine whether it's a right triangle or not. But now, let's call this one D1, D2. I will call this one D3 and D2. Now let's find D1. Let's find this distance now. Okay. So D1 is x1. Let's use this one as x2. So -6 minus x1 is 3 squared plus y2 is this one minus y1 is 1 squared. So this is square root of, so what is this? -6 minus 3, negative, it should be -9 squared plus 2 minus 1 is 1, 1 squared is 1. So what is -9 squared? Well, -9 squared is 81, and we have plus 1. Therefore, this is square root of 82. Okay. And what is D2? D2 is this distance. So here, use different color so that we can see it. Okay. We have 3 minus 1 squared plus 1 minus -2 squared. And this is 3 minus 1 is 2, 2 squared is 4, 1 minus -2. So this becomes plus, therefore 1 plus 2 is 3. Oh, sorry. And then we have to square it, so 3 squared is 9. And therefore this is square root of 30. And then we have the last one, and that is, use again another color. So D3. D3 is this one, so this becomes -6 minus 1 plus 2 minus -2 under square root. And -6 minus 1 is -7. -7 squared is 49, positive. 2 minus -2, negative becomes positive. So 2 plus 2 is 4. 4 squared is 60. And this one is, what is this? 65, right? Okay. So I'm not simplifying them. Probably this is 5. Yeah, I think you can simplify this one, but we don't need that one because the question is to see whether these 3 points represent the vertices of a right triangle. Okay, if these are the correct vertices of a right triangle, that's the question. Now, what property do we know about a right triangle? There is one special property of a right triangle, and that one is that special property is so if you have a right triangle, suppose this is a right triangle, and if we call this C and these two are AB, okay, this is the right triangle, this is the 90 degree. So we know C square is A square plus B square. This is the special property about a right triangle that differentiates it from other types of triangles. Now, the question is, since we know all the distance, we know the 3 distances, we have D1, D2, and D3. And out of all this, the longest is the first one, which is D1. So always the longest one has to satisfy this one. This is the longest one. C is the longest one, and those are the 2 short ones. Now let's see if those distances satisfy this condition. C squared, in our case, it will be D1 squared equals to D2 squared plus D3 squared. Okay. Now D1 squared is D1 is square root of 82, and we have the square. D2 is what was it? Square root of 13 plus D3 is square root of 65, and all of them, they have square. Now the square root and square, they cancel each other. Therefore, we have 82 on the left, 13 here, 65 here. Now here we have 82, and this is 78. Okay. Now what do we say? Well, these are not equal, right? Therefore, the answer is no. Okay. These 3 points, they don't represent the vertices of a right triangle. Okay, they don't form a right triangle, which means this triangle that I draw here is, it's not a right triangle. Okay, so this is how you check it. First, what we did is we find the distance, and then we check using this special property of a right triangle. We check whether the 3 distances satisfy this condition or not. Okay, that's what we do. Now the question you may ask, like, how do I choose D1, D2, and D3? Or how do I choose C, A, and B? Well, always take C as the longest distance, okay? It doesn't matter whether you call it D1 or D3 or D2 or C or A or B, but always the longest distance, you keep it by itself on one side and the sum of the 2 squares on the other side, okay? So this C is the longest distance always, which is opposite to the right triangle. Always the longest is opposite to the right triangle, to the right angle, sorry. Okay. Now the next is, suppose you have an equation of 2 variables, just similar to this one. Now we can graph such equations by plotting points. Well, we will learn other type of other ways of plotting, but for now, let's start with this one. Now, when you have such equation, now let's consider this equation. This equation, which is y equals to x plus 2. This is a simple example. But in this case, we have 2 variables. One is x and the other is y. And the solution set to this one is represented by a paired value x comma y, just by a point, because here we have two variables. Therefore, we need to find a point that has x and y values, which makes this one true. Okay, when you substitute the values of y in here and the value of x in here, then this has to be true. And this is what we call the solution. So solution set to this one, it's not only one point. We can have million points, that we can have infinitely many points, okay, that satisfy this condition. And we will see those points. And of course, the set of all those points, we call it the solution set. And we have seen this one before when we were dealing with solving quadratic equation or linear equations. Now, suppose we have this solution given on the left side, and let's see if this satisfies this condition, this equation in two variables. Now, the first value is always for x, and the second one is for y. Now, if I plug those values in here, the first one in place of x and the second one in place of y, so I will have 2 equals 2. This is y, so I take the second one. X is 0 plus 2. Therefore, this is true because we have 2 equals to 0 plus 2, which is 2. Okay. Therefore, this is a solution to this equation. How about the second solution? The y value is -2, so we have -2 equals to x value is -4 plus 2. -4 plus 2 is again -2, so we have -2 equals to -2. Again, this is a solution. And the last one, the value of y is 1, the second term, the second value, and the value of x is 0 plus 2. We have 1 equals 2, and this is not a solution to this one. You can come up by with your own solution to this one because it's easy. You can see the solution, I believe. So we can find a lot of these solutions. We can have infinitely many. We have, of course, infinitely many solutions. And this solution or solution to an equation of two variables, like this example, are represented by a line. Okay, just by a line on the coordinate plane, on the rectangular coordinate plane. And the graph of all those solutions is called graph of the equation. If you connect, if you draw all these points, the solutions, not the non-solution, this is not a solution. But if you combine or if you connect all the solutions of this equation, and that line is what we call the graph of the equation, okay? And I will show you what I mean by this one. Now, let's graph this one by plotting points. Let's put some space here. Now, what we do is we prepare a table. Let's say here I'll put X, and here I will put Y, and here the value of Y squared minus X plus 1. Okay. Now what we do is, well, we don't need the second term actually. We just solve it. Okay, so now what we do is we pick value of X arbitrarily. Okay, just pick arbitrary value. So usually what we do is we pick somewhere around 0 because that's much more easier to evaluate in this equation. So we start with 0, value of X 0, and then give it 1, and then maybe -1, and then maybe 2. I think it's better to start with to go in order. Yeah, so let's start with -2, -1, 0, 1, and 2. You can go beyond this one, or you don't even need all this. You need only 2 points, because it's, well, not 2 points, of course, because this is quadratic. But if it's a straight line, we need only 2 points. But in this case, we need more than 2 points. Okay. Now, we have this equation, and if you pick these arbitrary values, let's take one by one. For x equals to -2, you plug these values in here, this value in here, and see what the solution to you solve for y. Therefore, we have y squared minus -2. -2 is value of x. I'm starting with the first one. Plus 1 equals to 0. And y squared minus 2, sorry, this is plus 2, plus 1 is 0. Then y squared is -3. So here, y is square root of -3. And you remember what this type of number is? Well, this is plus or minus, actually. This is an imaginary number, right? And we don't need this one now. We need an only real numbers. We are not dealing with imaginary numbers for now. Okay. Therefore, I will delete the first one. Okay. So what I need for this is I will pick arbitrary values, but not arbitrary since it's a quadratic value now. I will pick those values which satisfy the this square root, because I will take the square root of this one. Therefore, what value do I have? Let's say if x is 5, if x is 0, not -1, should be 1. Let me start with 1. Okay, x is 1. When you plug 1 in here, we have y squared equals to, this is 0, because we have -1 plus 1, this is 0. So y squared equals 0, therefore this is 0. And if I pick here 2, okay, so -2, what I have is y squared minus 2 plus 1 is 0. So this is -1. I have y squared minus 1 equals 0. So this is y squared equals to 1, and y is plus or minus 1 because the square root of this one. Therefore, I have plus or minus 1 here. Okay, I have 2 values because this is a quadratic form. And then I can pick, if I pick 4, no, if I pick 3, I pick 5. I'm choosing this because I'm trying to find a perfect square root. Okay, that's why. So if I put 5 in here, it will give me a perfect square. Y squared minus 5 plus 1 is 0. So this is -4. Therefore, I have y squared equals to 4, and y is plus or minus 2. Therefore, here I have plus or minus 2. So this is good enough. Now, in total, how many points do I have? I have, I'm gonna rewrite this one. So 2, -1, 2, 1, the plus or minus. And I have 5, -2, and 5, +2. Okay, so these are good enough. Now let's put these points on the plane. I'll use this color. So 1, 0 is x value is 1, and y value is 0. So the y value is 0 means it's on the x-axis. On the x-axis, the y value is always 0. So 1, 0, 1, comma 0 is here. The x value is 1, but the y value is 0. And 2, comma 1, negative 1 is this one. And 2, comma positive 1 is above the x-axis, which is this one. 5, comma negative 2. Well, 5 is, this is 2, 3, 4, 5. This is 5. So 5, comma negative 2 is right here. And 5, comma negative, positive 2 is right here. Okay. Now, can you see the shape of the graph? The graph now will look like something like this. That's not the best one, but yeah. So the shape will be something like this. So this is a graph of y squared minus x plus 1 equals to 0. Okay. So this is how we draw a graph of an equation by plotting points. What we do is we pick values for x and then we solve for y. That's how we do it. So this was a bit tricky because the way I chose the values was values that satisfy the perfect square, because sometimes, as you have seen earlier, it may give me some imaginary values like this one, which I don't want them in this case. Or sometimes it may give you even not imaginary, but something like square root of 3. And the thing is, how do you find square root of 3? You have to use calculator probably to convert this one to decimal, and then that will be 1 point something, and then you have to guess, well, maybe square root of 3 is somewhere around here or something. So instead of that, you pick values of x which give you an integer values of y. Okay, perfect square. That's why I was picking special values. Otherwise, it doesn't matter. It's not a problem about that. As long as you get a real number, not imaginary number, of course, but if it gives you a real number, you can still choose as value of x. Okay. Okay. And then the next is the next property, or the next important thing that we need in when we deal with graphing of equations or graphing of functions are the x-intercept and the y-intercept. Now, what are x-intercept and y-intercept? Now, when we plot graphs, some of the graphs, let's say we have a straight line. Let's say this is a graph of some equation. So the graph touched the y-axis somewhere, okay? And then it touched the x-axis somewhere. So this is what we call the y-intercept, and this is the x-intercept. So the points, these points are the points where the graph touches the x and the y axis, okay? X-intercept means the point where the graph touches the x-axis, which is this one, and y-intercept means the point where the line or the graph touches the y-axis. Now the question is, what does they look like, or what is the form of an intercept for any function? What's the form of the intercept? For example, what is this point? If let's say the graph touched the y-axis at this point. Now, can you tell me what this, what is this point? What's the coordinate, the point of this one, the xy values of this point? So if, let's say this is 1, well, the y value is 1 because we have 1 vertical distance here, 1 unit of vertical distance. How about the x value? The x value is 0. Okay, because at this point, horizontally, vertically, if you go up and down, the x value is 0 because here x is 0. Okay, because we're not changing horizontally, we are just changing vertically. but x is horizontal distance, right? It goes left to right. But if I don't change the horizontal distance, if I'm going up or down, the value of x doesn't change. It's the same like this one. So here the value of x is 0. Therefore, all along this y-axis, the value of x is 0. So any y-intercept has this form. The x value is 0, but the y value is some value. We call it b in this case. Okay, so it has 0, comma b. Well, sometimes the intercept could be the origin. Okay, it could pass through the origin, which means the x and the y-intercept are the same, the origin. Okay, and the x-intercept has the form a, comma b, which means wherever it touches the x-axis, wherever the graph touches the x-axis, at that point, the y value is 0, which means at any point on the x-axis, the y value is 0, but the x value could be 0 or different from 0. Okay, that's why we have a, comma b. Now, how do we find the x and y intercepts? Suppose we have the equation, let's say the origin, the first one that we've seen. If I have this equation of two variables, how do I find the x-intercept and the y-intercept of this for this function, for this equation? To find the x-intercept, what we do is we substitute 0 for y and then solve for x. For example, for this one, just plug 0 in here to find x-intercept. Put 0 in, substitute 0 in here. Then we have 0 equals to x plus 2. Now we subtract 2 from both sides. Then we have x equals to negative 2. Okay. Now, remember, the x-intercept and y-intercept are points. They are not just numbers. Okay, they are points. And a point is represented by a coordinate, a pair of values. Okay. Therefore, do not leave it this way. When you're asked to find the x-intercept, don't say it's x equals to negative 2. You have to write it as negative 2, comma 0. Okay, this is the x-intercept. It should be a point. And for the y-intercept, we substitute 0 for x and then solve for y. Okay. Example for this equation, this simple equation. To find the y-intercept, just plug 0 in here. I have y equals to 0 plus 2, which means y equals to 2. Therefore, the point is what? Well, the x value is 0. Already we chose 0. We know it's 0 because it's y-intercept. And the y value is 2. So, suppose if you draw, graph or if you plot this equation, the graph of this equation, it will touch the x-axis at this point, okay? And it will touch the y-axis at this point. That's what we mean by x and y intercepts. So if you have something like this, you don't need even to draw it. Of course, it's good to draw, it's not a problem, but by just using this idea or this, if you get this idea, you can just find the intercepts by just using this method. Now we have this quadratic form, and we are asked to find the x and y intercepts. Okay. Now how do we find it? Let's start with x-intercept. Okay. So to find x-intercept, what do we do? Well, we just substitute 0 for y. Okay. Therefore, it will be x squared equals to negative 0. Of course, just plus 16. And this is x squared equals, this is 0, just 16. Therefore, what do we have? X equals to plus or minus, don't forget this one, 16. Okay, do not forget this one, because square root of this is plus or minus 4. Because the answer that satisfy this equation are both positive and negative 4. If you have negative 4 square, it gives you 16. If you have positive 4 square, it gives you 16. Okay, so both of them, they satisfy this condition. Now I have two different numbers here, two different answers. Now what is the x-intercept here? Well, in this case, we have two different x-intercepts. The first one is negative 4, 0, and the second one is 4, 0. And we expect this one because it's a quadratic equation, quadratic form. And for quadratic forms, usually they are, always they are curves. Okay, the curve could be, they are parabola. They could be this way, they could be this way. We will learn about this one. They could be this way, they could be this way, and sometimes they could be slant, kind of not horizontal, vertical, but halfway, something like that. But anyway, they are always parabolas. If you have square here or square here, they are parabolas. Okay, that's why if you have parabola, of course, it can touch the x-axis at two different points. For example, this is touching the x-axis at two different points. That's why I have two different intercepts here. Or sometimes if it is, for example, this way, it can touch the y-axis at two different points. In that case, you would have two different y-intercepts. Okay, and then what is the y-intercept? What is the equation? Okay, and the y-intercept is well, how do we find the y-intercept? We plug 0 for x, therefore I will have 0 squared equals to negative y plus 16. So this is 0, negative y plus 16. And we subtract negative 16 from both sides. Therefore, I have negative 16 equals to negative y. Again, I have to get rid of this negative. And to do that, what do? We multiply both sides by negative 1. Don't worry, we don't have to reverse this one because it's equality. But when it's inequality, we reverse this one. Remember that. So here we have 16, and this is y. So for convenience, I will rewrite this one as y equals to 16. Okay. Now, what is the point? Because it's an intercept, it should be a point. It's not. We don't leave it this way. So the point is the x value is obvious. It's 0 because we are talking about intercept, and the y value we found it. So this is the intercept. Now you can guess about the graph now because we will learn this one, but just for your knowledge, I have these two intercepts, x-intercepts, negative 4, 0 and 4, 0. Okay, so if I have negative 4, 0 is somewhere in here, and 4, 0 is somewhere in here. So I know the graph touched the x-axis at these 2 points. And where is the y-intercept? This is the y-intercept, and this is up here, 16. I don't think I can write it, but let's say 16 somewhere here. Let's say this is 0, 16. Now, what do you think? We said earlier, the graph is a parabola. It's a curve, right? So do you think it opens downward or upward? Don't worry, we will learn this one. But just since we're talking about intercept, I want you to have an idea. Just by looking at this intercept, we can see whether it's opening downward or upward, okay? And as you can see, the intercept is here, the y-intercept, and the x-intercept is here. So it cannot go something like this. It cannot go like this one. If it could go something like this, then we would have had another intercept here, but we don't have intercept here. So that means it doesn't touch the y-axis below, other than this point. It only touches it at this point. Now, in order that to happen, the graph has to look like this one. Okay, something like this. No, it doesn't curve, just straight. Okay, so this is how it will look like. This is how it looks like. But you don't need to worry about this. We will learn this one in detail, okay? Because this is quadratic, this functions and stuff. We will learn this kind of things, okay? But in general, I want you to understand, like, because the intercept, they give you a lot of information about the graph, particularly when it's parabola, okay? All right, so this is all for today, and we will start the next section in the next lecture. And yeah, see you in the next lecture.